Now let us try to understand about the concept of friction without going into the much theoretical part of the friction. I found many students having problem with the direction of the frictional force. Sometimes it acts forward, backwards, and whatever the things are. The definition of friction always opposes the relative motion point of contact. Examples, like we go with the basic, like I take this floor, block is kept. Now if the block is starting moving forward with a velocity v, this is block, this is ground. So velocity of block with respect to ground, always we will take about the relative motion, always, and relative motion is nothing but the subtraction. So I will take this as velocity of block minus velocity of ground. Velocity of block is v minus ground 0, this is v. That means the relative motion of the block with respect to ground is nothing but in the forward direction. So frictional force on the block will be in the backward direction in this way. Later on we will discuss about what kind of frictional force is, whether it is maximum or not. Next concept we will talk about that. And on the ground, frictional force will act in the forward direction. So I put another one, friction always forms an action and a reaction pair. So keeping these two things into mind, suppose I say there are two blocks in this way, one block is this, one block is this. Suppose it is moving with a velocity 8 meter per second, this is moving with a velocity 2 meter per second. Let this block A, let this block B. So I want to find out the direction of the frictional force acting on A, direction of frictional force acting on B, direction of frictional force acting between B and ground. So I will take, when I want to find out the frictional force acting on A, so I will take the relative motion of A with respect to B. Always keep that into mind whenever you want to find out the direction of frictional force acting on a particular body. You should always find the relative motion of that body with respect to the surface on which the body is making motion. So here body A is making motion on body B, so I will write velocity of A with respect to B is nothing but velocity of A minus velocity of B. This is 8 minus 2, this is 6 plus. So relative motion is in the positive direction, so always it opposes the relative motion. Frictional force acting on A will be in this direction, and the same frictional force F1 will act on B, keeping that in mind, in this direction, F2. And on ground, obviously that we have already discussed just before that, relative motion of B with respect to ground is in the forward direction. Frictional force acting on this will be in this backward direction, and frictional force acting on the ground will be in this way. So this is relative motion of B with respect to ground is in the forward direction. So frictional force acting on B due to ground will be in the backward direction. The same frictional force will act in the opposite direction on the ground, and this is meaningless to show this, but I am showing you about saying that frictional force always forms an action and a reaction pair. Frictional force is directly proportional to normal force. When you remove the proportionality sign, frictional force is mu s into n, where I write mu s is coefficient of static friction. Here I mention one thing, friction is a self-adjusting force. When the body slips or have a tendency to slip, then F equals to mu s into n, where n is normal force. When the body is moving, then F is equal to mu k into n. What is mu k? Mu k we take it to be coefficient of kinetic friction. Generally, in many problems involved with physics, they say that mu s is equals to mu k, they give it the values. This is very simple. When the body is moving, then F is equal to mu k and will come down to this point in a later on way. Here the friction is a self-adjusting force. When the body slips or have a tendency to slip, then F is equal to mu s into n. Let us take a basic example. I take this floor block, I make it mu s is suppose 0.3, 10 kg. If somebody asks you what is the frictional force, in this case here the frictional force will be 0, because no applied force, no frictional force. Suppose somebody says this is a 10 kg, I am applying some 1 Newton frictional force, I will calculate F max. F max is mu s into n, that is 0.3 into 10 into 10, that is 30. So here maximum static frictional force is 30 Newton, but since I am applying 1 Newton force, frictional force will be 1 Newton. Now instead of F is equal to mu s into n, and friction is a self-adjusting force, so I put a new part over here. F is in this, and when the body sleeps or have the body tending to sleep, then I write F max equals to mu s into n. So suppose instead of 1 Newton, I am applying over here exactly 30 Newton. Now the body is under the tendency to slip. Since the body is under the tendency to slip, the frictional force will be maximum over here is 30 Newton. Now you apply a more force than 30 Newton, then the body slips, and obviously if kinetic friction is given, we will take F is equal to mu k into n, and there will be an acceleration. Net force is equal to 30, more than 30, suppose I am applying 35 Newton. So if mu s is equal to mu k given, so obviously the acceleration will be 35 minus 30 divided by 10. These are the very simplest cases where we discuss about that. Anybody knows about this kind of things where frictional force is 0 and all those things. The problem mainly involves when the body is kept on another bodies. So there is a way to find out. F is directly proportional to normal force. F is equals to mu s into n. Mu s is coefficient of static friction. We take friction is a self-adjusting force. That means F is lesser than equals to mu s into n. When the body slips or have a tendency to slip, then frictional force is maximum, mu s into n. N is equal to normal force. When the body is moving, then F is equal to mu k, and mu k is equal to coefficient of kinetic friction. And these are the basic examples which I have taken. And friction always makes an action and a reaction pair that I have discussed just earlier. Now let us involve all these concepts in a very simple way. Like suppose I say this is a ground, this is 4 kg, this is 2 kg, here it is smooth, here I give you mu is equal to something around 0.2, and here I take it to be, suppose I say 5 Newton. The same question I give here, same 4 kg, same 2 kg, I give you something around 36 Newton. and here I give you same mu is 0.2. Now what is the frictional force, how to find out the direction of frictional force, whether they are moving together as one body, when they will have maximum static frictional force, when they will have a self-adjusting frictional force. Let us discuss about it. Whenever this kind of problems are given, step 1, calculate A tendency. A tendency means acceleration. In Newton's laws of motion, it is said, whenever a force is given, unbalanced force is given, the body tends to accelerate in that particular direction. So let us calculate the A tendency for it. It is not necessary that 2 kg is accelerating with a different acceleration or 4 kg is accelerating with a different acceleration. Let us calculate the A tendency first. All these blocks, according to Newton's first law of motion, will have the tendency to accelerate in the forward direction. Whether this individual block A or individual block B are having different accelerations or not, that I don't know. We will calculate that. So let us calculate A tendency. A tendency is 5 divided by 6 meter per second square. And in the side I write F max. I calculate and write it, just 0.2 into 2 into 10. It is nothing but 4. I keep it like this. Now this 2 kg is having a tendency to accelerate in the forward direction with an acceleration 5 by 6. Now the relative motion of A with respect to B obviously will be in the forward direction. So frictional force acting on A will be in the backward direction. So I write it like this. This is A. Here I have 5 Newton. Here I write F. I don't know whether this F is maximum or not. If this body A is having a tendency to have maximum or it is a tendency to have slipping condition, then this F will be maximum. But I don't know whether this A is under slipping conditions or not. So here I write A tendency. So I write it 5 minus F is equal to mass of A is 2. 2 into A tendency is 5 by 6. So this becomes 3, 5 by 3. Or F equals to 5 minus 5 by 3. So this becomes 15 minus 5, 10 by 3. So this is 3.3 Newton. Now if you look carefully, this calculated, so here I write F calculated. Here this F calculated is lesser than F max. So obviously here, since F calculated is lesser than F max, so these two bodies will move together as one body with an acceleration 5 by 6, and the frictional force acting between these two blocks will be nothing but 3.3 Newton. I repeat again, we will calculate whatever the problems are, we will just calculate first A tendency, keep in this side what is F max. We will just write A tendency is net force. Remember, A tendency is net unbalanced force. Net unbalanced force divided by total masses under acceleration. So since 2 kg and 4 kg block are under acceleration, so net unbalanced force is F. So if I say if there would have been any force, frictional force between the ground, then I would have taken 5 minus that frictional force acting between the ground divided by total masses. So remember, here I am not giving, for my sake of convenience or simplicity, I am taking the ground is smooth, but it is not always necessary that the ground will be given smooth. If ground is given with some static frictional force, then you have to take 5 minus net frictional force acting between the ground divided by total masses. But since the ground is given smooth, so here I take it 5 divided by 6, 5 meter per second square. Then I use that since body A, the relative acceleration of body A is in the forward direction, frictional force will act in the backward direction. I use Newton's second law of motion. F minus F, 5 minus F is equal to 2 into A tendency, 5 by 6, 5 by 3. So F is equal to 3.3 Newton. So since F calculated is 3.3 Newton, which is lesser than F max, so these two bodies will move together as one body with an acceleration 5 by 6 meter per second square with frictional force 3.3 Newton. So if I ask you this block A and block B, whether they will have some different accelerations, this block A and block B will not have any different acceleration. They will move together as one block with an acceleration 5 by 6. Relative acceleration will be 0. Let us take the same thing over here. A tendency, I calculate it first. A tendency is 36 divided by 6, 6 meter per second square. I take on the upper block, that is A. Here it is 36 Newton. Here it is F. Here it is A tendency. So I write 36 minus F is equal to 2 into 6, or F is equal to 36 minus 12, that is 24. And obviously this 24 is nothing but greater than 4. So obviously this A and B will not move together as one block. So here I write A and B will have different acceleration. So on A, if I take this 36 like this, now I have to take, because we got to know that A and B will have different accelerations. That means A is slipping over B. If A is slipping over B, then frictional force acting on A will be maximum, as discussed earlier. So maximum means here it will be 4. Don't substitute this 24 again. So here it is, acceleration of A is 36 minus 4 divided by mass of A is 2. So that is 32 divided by 2. That is 16 meter per second square. And on B, since frictional force makes an action and reaction pair, on A 4 Newton is acting in the backward direction, on B it will act in the forward direction, that is 4. So acceleration of B will be 4 divided by mass of B is 4, 1 meter per second square. So if I ask you what is the relative acceleration between A and B, relative acceleration between A and B will be 16 minus 1, that is 15, and both the blocks will be under slipping conditions with having different accelerations, and frictional force acting between these two blocks will be maximum. Let us discuss about few questions related to all those things. Let us have some questions in this. In the figure shown, find the force of friction on the block in each case. Now he is giving 3 cases over here. Question number 1, it is 4 kg, F is 20 Newton. Here I give you mu s is equal to 0.6, mu k is equal to 0.4. Next case, this is a block of mass 2 kg. Here F is equal to same 20 Newton over here. Here mu s is 0.6, again mu k is equal to 0.4. And the third case, it is 20 root 2 Newton acting at an angle of 45 degree. Here it is mu s is again given as 0.2 and mu k is equal to 0.1. Now already I have said you, when the block are accelerating, so the frictional force will be nothing but a kinetic frictional force. But before we know that they are accelerating or not, let us calculate. In both 3 cases, I write Fs max. Fs max is nothing but here 0.6 into 4 into 10, that is 24 Newton. Here I write, and Fk max, Fk not max, Fk 0.4 into 4 into 10, that is 16. Here also I will write Fs max 0.6 into 2 into 10, that is 12. Fk I write it 0.4 into 2 into 10, that is 8 Newton. In this case, it will be resolved in this way. This is 20 root 2 sine 45, which cancels out. This is 20. Here the normal force is like this. Here it is 60. So, and forward direction, this is 20 root 2 cos 45. Again cancels out. So here n plus 20 is equal to 6g. N equals to 6g minus 20, that is 40. So normal force is here is 40. So F is max, I will write it here, 0.2 into 40, that is 8. Fk is 0.1 into 40, that is 4. Now here maximum static frictional force is 24 Newton, but I am applying 20 Newton. So obviously this 4 kg block is having zero acceleration. So here frictional force is a self-adjusting force. So in this case, frictional force is nothing but will have 20 Newton. Let us go in this case. Here 20 Newton is the applied force. Maximum static frictional force is 12 Newton. So obviously 2 kg block will be under the state of acceleration. It will move, it has already slipped. So here frictional force will be kinetic. So F will be nothing but 8. If you look carefully here the applied force is 20 Newton, maximum static frictional force is 8 Newton. Obviously this applied force is greater than the static frictional force. So it is under the state of acceleration. When it is under the state of acceleration, frictional force 8 Newton. Frictional force is nothing but 8 Newton, maximum static frictional force. So it is under the state of acceleration because the applied force is 20 Newton. So when it is under the state of acceleration, frictional force acting on 6 kg block will be kinetic. So kinetic means the frictional force will be nothing but 4 Newton. So the options are given: bit A as 10 Newton, 4 Newton, 2 Newton, bit B 20 Newton, 8 Newton, 4 Newton, bit C 30 Newton, 12 Newton, 6 Newton, bit D 5 Newton, 2 Newton and 8 Newton. The correct answer will be bit B option, which is nothing but 20 Newton, 8 Newton, 4 Newton. We'll go to the next question. Now it's given there is a conveyor belt. This conveyor belt is moving with a constant speed of 6 meters per second. A small block is just dropped on it. Coefficient of friction between the two is given as mu equals to 0.3. That means mu s is equal to mu k equals to 0.3. Find bit 1, it's given the time when a relative motion between them will stop. Bit 2, displacement of block up to that instant. Now here I found many students having problems with the direction of frictional force, all those things. Now the block is just dropped on it. So let us take this. Always I said, when I want to find out the direction of frictional force acting on the block, I should always take the relative motion. So let us say conveyor belt, I am showing it to be C. So velocity of block with respect to conveyor belt is equal to velocity of block minus velocity of conveyor belt. So here I introduce a little funny thing. Velocity of block is 0 because it is just dropped. Velocity of conveyor belt is in the forward direction. So I write it forward. So minus of forward direction means backward direction. That means a relative motion of block, that means velocity of block with respect to conveyor belt is in the backward direction. So frictional force acting on the block B will be in the forward direction. And since it is having a velocity, so it is under slipping condition, so frictional force will be nothing but in this direction. What this frictional force will do? this frictional force will try to accelerate this block. Now it is accelerating this block until and unless relative motion stops, means velocity of block must be equals to velocity of conveyor belt. That means velocity of block minus velocity of conveyor belt should be equals to 0. That means the question is saying the time when relative motion between them will stop. That means this frictional force is trying to accelerate this block to a velocity to that of the conveyor belt. So during that time only, at that time only the relative motion will stop. So here I say frictional force is nothing but mu into m into g. So obviously acceleration of block B will be nothing but mu g. So I can say let at time t the relative motion stops. So here I can write velocity of block will be nothing but 0 plus mu g into t, because initial velocity of block B is 0. So Vb equals to mu g into t. So I can write this must be equals to velocity of the conveyor belt, and velocity of the conveyor belt is given as 6. So I can write t is equal to 6 divided by mu g. So 6 divided by mu is 0.3 and g I take it to be 10. So this is 6 by 3, that is 2 seconds. So the time when the relative motion stops is 2 seconds, and displacement obviously since the frictional force acting on the block B is in the forward direction, that frictional force is providing an acceleration which will make this block B move in the forward direction. So there will be some displacement of this block in the forward direction. So I can write displacement of the block is half into A into t square. So half into acceleration of B is mu g into t square is 4. So half into 0.3 into 10 into 4. So this becomes 2. So 3 into 2, 6 meter. So the options are given as bit A 3 seconds, 2 meter, bit B 1 second, 6 meter, bit C 2 seconds, 6 meter, bit D 2 second, 4 meter. So the answer will be here. Will be C, which is nothing but 2 seconds, we got it, 6 meter. We move to next question number 3. 2 kg, 1 kg. Velocity of this is given as 2 meter per second. This is 8 meter per second, and this is given as smooth. Now he is saying coefficient of friction between the two blocks mu is given as 0.4. The blocks are given velocity is 2 meter per second and 8 meter per second in the directions shown. Find the time when the relative motion between the two blocks or relative motion between them will stop. Bit 2, common velocities of blocks up to that instant. Bit 3, displacement of 1 kg block up to that instant. G is given as 10 meter per second. Obviously this is a state of slipping conditions, so frictional force will be maximum, that we know about it, because whenever a force is applied on a body, then we will think about the self-adjusting force. Otherwise when the velocities are given, we will think about the frictional force is maximum. So I write one point over here. When velocities are given, think F equals to mu s into n, and when force is applied on a body, think F is self-adjusting force. This thing will help you when we go to a chapter called rotational mechanics, when frictional force is nothing but I write like this. when I solve problems related to rotational mechanics or in frictional force also, I take F is greater than equals to 0, lesser than equals to mu s into n. It helps lot of things to know about the nature of frictional force. So here velocities are given, so frictional force will be maximum. So let us calculate that frictional force, that is 0.4 into 1 into 10, that is 4 Newton. I don't know about the direction of frictional force in which on 1 kg block frictional force is acting, on 2 kg block frictional force is acting. To know about the direction of frictional force acting on 1 kg block, I always said whenever you think about frictional force, think about a relative motion, never think about motion. Never think about motion, always think about relative motion. So whenever you think about frictional force, whenever frictional problems related to frictional force comes into account, always think about relative motion, never think about motion. It's a common tendency I have seen among students to think about motion and find the direction of frictional force. Never do it. So to find out the direction of frictional force on 1 kg block, let us say I give you block A, block B. Velocity of A with respect to B is velocity of A minus velocity of B. Velocity of A is 2 minus 8, this is minus 6 meter per second. So here relative motion of A or velocity of A on B with respect to B is in the backward direction. So frictional force always opposes the relative motion. So on A block, frictional force will act in the forward direction, which is nothing but equals to 4 Newton, because it is in slipping condition. When velocities are given, think F is equal to mu s into n. On 2 kg block, as frictional force makes an action and reaction pair, so frictional force on this block B will be in the backward direction. And I write down the initial velocities. Now what this frictional force do? This frictional force acting on block A will accelerate the block A. This frictional force acting on block B will decelerate the block B. Accelerate, decelerate, accelerate and decelerates. At one moment of time, when the relative motion stops, these two blocks definitely will be moving together as one block. That means I can say these two blocks are having the same velocities. So when the velocities are same, the relative motion or the relative velocity between individual blocks will be 0. Let us calculate those velocities. Let at time t relative motion stops. So velocity of A will be nothing but, let us calculate acceleration of A. Acceleration of A will be 4 divided by mass of block A. This is 4 meter per second square. Let us calculate the deceleration of block B. This is 4 divided by 2. This is 2 meter per second square. So velocity of A at any time t will be nothing but initial velocity 2 plus 4 into t. And velocity of B will be nothing but 8 minus, because this frictional force is retarding this block B, 2t. Now when the relative motion stops, VA must be equals to VB. 2 plus 4t is equal to 8 minus 2t, or this implies 6t is equal to 6, or t is equal to 1 second. Now the time when the relative motion between the two blocks stops is nothing but 1 second. In the bit 2 given, the common velocities of block up to that instant. You can substitute the value of t in any one of the equation. VA is equal to 2 plus 4 into 1, 6 meter per second. So obvious, or 8 minus 2 is 6 meter per second. So the common velocities of blocks up to that instant is nothing but 6 meter per second. Displacement of 1 kg block up to that instant. So displacement of 1 kg block means I am asking about A is nothing but UA into T plus half AA into T square. So initial velocity is 2 into 1 plus half into acceleration of A is 4 into T square is 1. So this is 2 plus 2 is 4 meter. Now displacement of block A in during that time 1 second is nothing but 4 meter. So options are given as, we can do in another way to find out the common velocities. Like if you little bit know about the conservation of momentum, I can, since we got to know that block A and block B together are moving with one velocity which we found out. So I can use, since frictional force is an internal force and I take this block A and block B as a system, and internal forces do not affect the conservation of linear momentum. So I can write here 1 into 2 plus 2 into 8 equals to 1 plus 2 into V. So this becomes 2 plus 16 is equal to 3V. So 18 is equal to 3V, or V is equal to 6 meter per second. We got it now. So we can use conservation of momentum whenever you have a little problem in finding the direction of frictional force, or if they ask you what is the common velocities of the block when the relative motion stops, you can use directly this conservation of momentum to find out. But this is the general way how things are happening. So here options are given as bit A 1 second, 6 meter per second, 4 meter, bit B 2 seconds, 6 meter per second, 4 meter, bit C 1 second, 3 meter per second, 7 meter, bit D 2 seconds, 6 meter per second, 7 meter, and the correct answer is nothing but bit A. So I write here answer is bit A, which is nothing but 1 second, which is nothing but 6 meter per second, which is nothing but 4 meter. Now we go to the next question, question number 4. Now if you look, the next question says, I give you the diagram of this. This is 2 kg. A coefficient of friction between two blocks shown in the figure is mu equals to 0.6. The blocks are given velocities in the direction shown in the figure. So this is 2 kg, this is 3 meter per second. This is 1 kg, it's given 18 meter per second. And this is smooth. The coefficient of friction between the two blocks is given as 0.6. So this is the common, earlier we did the velocities of both the blocks are in the same directions. Here I am trying to find out the velocities of both the blocks are in opposite directions. So here it is given coefficient of friction between two blocks is given as 0.6. So slipping condition, so I write F is equal to 0.6 into 2 into 10. First step we will do this, 12 Newton. Now time when relative motion between them is stopped, bit 2 common velocity of two blocks, bit 3 displacement of 1 kg block up to that instant, take G is 10 meter. So here we can find out common velocities by conservation of momentum, that is 2 into 3 minus 1 into 18 equals to 2 plus 1 into V. So here it is 6 minus 18 is equal to 3V, that is minus 12 is equal to 3V, or V is equal to minus 4 meter per second, which says that finally 2 kg block is moving in the opposite direction with a velocity 4 meter per second, and this 1 kg is same as 4 meter per second. That means we can say about it, frictional force acting on 2 kg block will be obviously in the, if I take relative motion into account, that is velocity of 2 kg block with respect to 1 kg block will be 3 plus 18, 21 in this direction. So frictional force acting on this 2 kg block will be in the backward direction. Frictional force acting on 1 kg block will be in this forward direction. So let us say let at time t relative motion stops. So I can write on 2 kg block, this is like this, 3 meter per second. Frictional force is nothing but I have calculated 12 Newton. Let us say this is block A, this is block B. So A of A will be 12 divided by 2, this is 6. And on block B, frictional force is in this direction, which is nothing but equals to 12 Newton. So this will be nothing but 12 divided by 1. So here it is having 18 meter per second. We will take this as positive, this is negative. So here I will write let velocity of A will be 3 minus 6 into t, and here velocity of B will be minus 18 plus 12 into t. These two velocities will be same. 3 minus 6t is equal to minus 18 plus 12t. So this becomes minus 18t is equal to minus 18 minus 3, minus 21 cancels out, t is equal to 21 by 18. So 3637 1 point second. Now the time where the relative motion stops is nothing but I can write 7 by 6 seconds, it will be fine because in the options 7. So the time when the relative motion stops is 7 by 6 meter. Velocities of the two blocks I can calculate here in this 3 minus 6 into t or minus 18 plus 12 into t. We have already calculated v is equal to minus 4 meter per second earlier. You can substitute the value 7 by 6 in this. We can get VA is equal to 3 minus 6 into 7 by 6. So 3 minus 7 is minus 4 meter per second. And the displacement of 1 kg block up to that instant. So displacement of 1 kg block up to that instant I can calculate. S of B is equal to UB into T plus half ABT square. I will take the directions into consideration. So UB is nothing but minus 18 into time I got 7 by 6 plus half into AB I got it nothing but 12. T square is 7 by 6 whole square. So we can calculate this. Minus 21 6 plus half plus 6 into 7 square by 6 square cancels out. So minus 21 plus 49 by 6. So this is 6 12. So options are we got time at 7 by 6 seconds, velocity we got as 4 meter per second, displacement of 1 kg block we get as minus 12.83. Minus means it is moving in the negative direction, that means displacement is 12.83. Options are given as bit A we got as 7 by 6 seconds 4 meter per second comma 12.83 meter, bit B 6 by 7 seconds 4 meter per second 11.83 meter, bit C 7 by 6 seconds 4 meter per second comma 0.58 meter, bit D 6 by 7 seconds 4 meter per second comma 0.58 meter. The correct option is bit A. So answer will be bit A, which is nothing but we got as time as 7 by 6 seconds, and the velocity we got as 4 meter per second, and the displacement we got as 12.83 meter. Now next question is a 2 kg block, question number 5. A 2 kg block is pressed against a rough wall by a force F equals to 20 Newton as shown in the figure. Find acceleration of the block and force of friction acting on it. Options are given as 4 meter per second square, 12 Newton. Bit B 8 meter per second square, 12 Newton. Bit C 4 meter per second square, 8 Newton. And bit D 8 meter per second square, 16 Newton. The diagram is like this. Let us take this as a wall. This is a block. It is pressed like this with a force of 20 Newton, 2 kg block. Mu S is given as 0.8 and mu K is given as 0.6. Now we have to calculate the acceleration of the block and force of friction. Don't always have a misconception that normal force is always equals to mg. Normal force can be anything. So here, if I look carefully, the normal force exerted, if I make a free body diagram on 20 kg block, what are the forces acting? Obviously this 20 Newton is acting like this. Normal force is like this, and obviously gravity will be there, that is 2g. Now the normal force, since the block is not accelerating in this way, so I can say the normal force is nothing but here 20 Newton. So here Fs max, I can calculate it, that is 0.2 into 20 is nothing but 16 Newton, and Fk I can calculate also 0.6 into 20, that is nothing but 12 Newton. Now the static frictional force is 16 Newton and the gravity is nothing but 20 Newton acting on it, that is weight. Weight acting on this block is 20 Newton, which is greater than the static frictional force. So since it is greater than the static frictional force, so obviously 2 kg block will accelerate. Now when it is accelerating, kinetic frictional force will come into account. So acceleration of 2 kg block will be nothing but 20 minus 12 divided by 2, 8 divided by 2, 4 meter per second square. So the acceleration of 2 kg block will be nothing but 4 meter per second square, and force of friction on 2 kg block will be nothing but kinetic frictional force, because it is in accelerating state, that is nothing but equals to 12 Newton. So the correct option will be, answer will be A, which is nothing but 4 meter per second square and 12 Newton. Question number 6. A 6 kg block is kept on an inclined rough surface as shown in the figure. Find the force F required to, bit 1, keep the block stationary, bit 2, move the block downwards with constant velocity, and bit 3, move the block upwards with an acceleration of 4 meter per second square. So and the options given are bit A 34 Newton, 40 Newton, 68 Newton, bit B 34 Newton, 40 Newton, 88 Newton, bit C 17 Newton, 20 Newton, 88 Newton, bit D 32 Newton, 40 Newton, 88 Newton. Now this is a 6 kg block. And this is given as 60 degree. Mu S is given as 0.6. Mu K is given as 0.4. Let us work out with the forces acting. One, it is 6G. This will be 6G. This will be obviously 60 degree. This will be 6G cos 60 degree. This will be 6g sine 60 degree. So here I write this is normal force acting in this way. So mg sine 60 degree, mg is 6 into 10 into, I can write sine 60 degree root 3 by 2, 30 root 3, approximately I take it to be 52 Newton. And here normal force, that is 6 into 10 into half, 30 Newton. And I will write it. Fs maximum is 0.6 into 30, that is 18 Newton. Fk is equal to 0.4 into 30, 12 Newton. Now it is given here, find the force F required to keep the block stationary. Now if you look carefully, bit 1, to keep the block stationary, if you look into the downward force, which is mg sine 60, is 52 Newton. 52 Newton is greater than 18 Newton. So obviously frictional force will be acting in the upward direction. So here it is, downward is 52, here is F, here I take it to be 18 Newton. So I will write F plus 18 Newton is equal to F plus 18 equals to 52, or F is equal to 52 minus 18. So the force is nothing but bit A. To keep the block stationary, the required force is nothing but equals to 34 Newton. Bit 2, move the block downwards with constant velocity. Okay. Now to move the block downward with constant velocity, obviously it is in slipping condition and the body has already slipped. The frictional force acting will be kinetic frictional force. So kinetic frictional force will be nothing but, here it is 12 Newton. So here I will write second option, F plus 12 is equal to 52, or that implies F is equal to 52 minus 12, that is nothing but 40 Newton. And bit C option, move the block upwards with an acceleration of 4 meter per second square. Now third option, now here it is given, we need to move the block with an acceleration of 4 meter per second square. So here mg is acting as, mg component is 52, and obviously it is in slipping condition, it is like, so I will write F minus 52 plus 12 is equal to, mass of the block is 6 into 4, that is 24, or F is equal to 52 plus 12 plus 24. So 4 to the 6 to 8, 5 and 6 to 8. So the force required force is 88 Newton to make the block move upward with an acceleration of 4 meter per second square. So the correct option will be bit B, which is bit 1 we got as 34 Newton, bit 2 we got is 40 Newton, bit 3 we got it, 88 Newton. So today we discussed all about the basics of friction, where we took about the self-adjusting forces. Frictional force always opposes the relative motion of the point of contact. Frictional force makes an action and reaction pair. Frictional force is a self-adjusting force. I said whenever you think about the velocities, think about frictional force is maximum. Whenever an applied force is given, check whether the friction is self-adjusting force or not. That means whenever the body is under slipping condition, the frictional force is maximum, that is mu s into n. When the body has already slipped, frictional force is nothing but mu k into n. Sometimes mu s must be equals to mu k given according to the given questions. So according to that, we always work out the questions given in the problems.